Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this second lecture of Module 7 on effect of geological structure on stability of dam foundation and tunnels. In previous discussion we have elaborated about the concept of tunneling and different type of treatments along with some basic background related to geological structures affecting the dams and tunnel project. In these lectures we will try to discuss about major geological structures like fold, faults and joints. In these lectures we are going to discuss about fold, fault, joints. Regarding this we are going to cover about major geological structures like fold, faults and joints also. We have already discussed about the concept of folds. Folds undulations formed by tectonic stresses under compression, under tension, under shear. Tension is rarely, but under shear. And the major elements of folds. Folds are crest, folds are limbs, folds are axial planes. On the basis of this we are going to define folds in different classes. So first, the highest point of an anticline is termed as crest and the lowest point is known as trough. Trough is related to syncline and we have already discussed what is anticline, what is syncline, what is antiform, what is the synform. When an anticline type of fold shows nearly equal depths in all sides with respect to crest, then this type of structure is known as a dome and the depressed part is known as a valley. Dome and valley. The inclined part of strata where the anticline and syncline merge are called as the limbs of the fold. This part is recognized as limb and this part, highest part, is recognized as crest. The axial plane is the imaginary divisional plane separating the fold into two nearly equal halves. In 3D, if we try to draw, we can here see fold equally, this line equally divide this fold into two equal halves. If we are going to extend this plane in three direction, then this is known as, because it is a containing axis, so this is known as axial plane. And at this point we are recognizing as hinge. The axial and axial line is defined as intersection of axial plane of a fold with the ground surface. Here ground surface is exposed. The plunge, also called as pitch of a fold, is the angle made by axial line with horizontal in axial plane. You can see if this may be horizontal, this may be inclined. If it is inclined, then this type of features, if the axial plane is inclined, we are recognizing as, and if we are going to measure this angle or opposite to this angle, this is the plunge. If we are going to categorize different type of folds, The folds can be divided based on geometry and based on genesis. Mainly we are going to concentrate about the geometry and then some limited type of folds based on genesis. Based on geometry, plunging fold, a fold may not continue for an infinite distance but dies away after a certain length. If fold is traced along the axial line direction, it may be found that the amplitude of an anticline decreases until it merges with the unfolded bed like this. This is a plunging fold. Here this line is representing plunge. If we are going to, this is the plunge angle. So this type of fold is known as plunge. If the mouth, the cross section of fold is of cylindrical nature and this axis is horizontal, this type of fold we are recognizing as cylindrical fold. So if this line moves toward the down, it becomes plunging fold. Next type of common fold is isoclinal fold. Iso means same, clinal means inclined. This represents about the dips. Both the limbs of fold dips in same direction become iso. Both the limbs of folds dips in same direction is recognized as, in 3D you can see in this way, and are equally inclined. The inclination of this and inclination of this same. If the axial plane is vertical, the fold is called as vertical inclined. So if this is vertical ranging 90 degree means like this, then it is called as vertical isoclined fold. If it is inclined, then it is called as overturned isoclinal fold. Another type is recommend fold, and here recommend fold you can see the axial plane of fold is horizontal or make a very low angle with the horizontal. Here the axial plane is a horizontal so the fold is like this. Here axial plane is lying horizontal and recalled as recommended fold. Then chevron fold, where the vortex point or crestal point is pointed in nature. This is also called as zigzag fold, has straight or planar limbs and angular this hinge. The bedding planes of the folds are parallel to the limbs. Here you can see these are the parallel to the limbs, and main feature is pointed crest. In some cases we are having two hinge, that is the box fold. Here one hinge, another hinge. It are also pointed at some corner. Monocline, it is a simple type of flexure formed by the bending of horizontal or very low dipping bed with anticlinal bed at the top and synclinal bed at the bottom. Next type of fold is a drag fold. Drag, as the name indicates, it is formed by the faulting or dragging of bed over one another. It originates with the competent beds such as sandstone slide past and incompetent beds such as shale. In such cases, due to dragging effect, there is a formation of drag fold and recognized as, you can see here, incompetent bed and the competent bed. So when this competent wave is moving, then there is some changes in features, and in this way there is a formation of drag fold. The thickness, this starts stretching, pulling apart and form a thin layer under this sandstone, sandstone shell or siltstone, etc. So drag type of fold generally is the relation of the incompetent and competent, where the incompetent bed is dragged by competent bed. This type of fold generally we observe in case of faulting. Another is stigmatic fold. As the name indicates, stigmatic is related to movement of snake. Movement of snake. This fold is a form in weak bed, yielding easily to deformation and assuming any shape impressed upon them by surrounding rigid rock. Stigmatic folds may result from the viscous flow of incompetent rock under the small stress difference, and hence it is known as flow fold also. The flow materials in incompetent beds, the flow material inject where it got the sufficient space, then started expanding, and in this way this type of fold is taking the path of snake movement. The quartzo-feldspathic veins and the pegmatites are commonly convoluted and buccal as stigmatic fold during high-grade metamorphism. Such type of folds we are going to observe in case of high-grade metamorphism, like in amphibolite facies, like in granulite facies, etc. During the formation of pegmatites, there is a varieties of stigmatic folding of different features. Faults. Fault is one of major structures formed under brittle domain caused by tectonic forces or caused by simple deformational forces, but due to deformational forces the dimension of fault is limited. But here the rock mass cannot separate into two parts and glides or flow past each other because of rigidity and friction. This results in a build-up of stress which lead to the accumulation of potential energy at to level of exceeding the strain threshold. One threshold energy is again the necessary relative motion is set along the brick veins in the rock to cause the fault movement. First, there is a formation of fractures. Initially, if there is some rock strata, you see about this pulling this rock strata, subjected to stress, compression or compression-induced tension or shear, then there is a development of discontinuity. Along this, due to overburden or due to the pulling by the gravity or due to the thrust from the lower side, one block is going to move with respect to another, either downward, either upward, either towards this fracture strike of fracture line, left side or right side. So in this way we are going to get the formation of fault. One view I try to show through this diagram. This A block and B block. B block was earlier part of this A block, but due to formation of this type of interface discontinuity, this B blocks started moving downwards and form fault. So we will discuss about the details in our coming slides. A fault is basically a shear failure since both compressive and tensile stresses act simultaneously, and a fault may be caused by present pressure or tension. A normal fault is provided by vertical pressure and a reverse fault is a result of horizontal thrust. Gravity fault may be produced at a place by releasing of the vertical pressure when the magma flow out from a part of earth crust, and the tension in the deeper strata may act in the same way by the removal of vertical support, and a fault may occur because of various types of tensile strength reduction in rocks of the upper strata of the earth. It depends on the nature of rocks, type of strain, and the rheology of rocks. A fault plane or failure surface is analogous to surface obtained by testing for the compression strength in test specimen. When we are going to test, there is a development of fault, then later on this going to shift. The angle made by the test in acute less than 45 in case of brittle material, whereas in plastic and ductile materials it may be more than 45. This analogy is applied to understand the faults, and we have already discussed. Here we are going to discuss about the elements of fault. Fault is the displacement of rock mass along weak plane called as a fault plane. This zone is known as fault plane, along which one block is going to shift detached from the another block. This is the fault plane. In a normal fault, the displacement is in downwards, but in case of the reverse fault, this B block is going to move up. They are going to move up here. The surface of the rock beneath a fault plane, we are going to recognize this part is a football below this surface, and above this surface is hanging wall. This part is a footwall, and this is the hanging wall. In a reverse fault, the movement along the inclined fault plane is up dip, and the term slip denotes the relative displacement between two blocks. The vertical component of slip is known as throw, and the horizontal component of displacement is known as heave. This part is known as heave, and this part is known as throw. In reality, a fault plane is rarely a clean-cut surface or surface, but it is mostly a zone of complex deformation containing shattered rock, and this shattered rock is recognized as fault zone. The fault can be range in dimension in tune of some kilometer to up to some centimeter and meter also. Sometimes a shear zone is also a crust zone that having some deformed and complex type of structural component, highly deformed in nature, fragile in nature from engineering point of view. It may range for few kilometers to a meter or even at a microscopic level. This, as the name indicates, shear zone, it is formed by the shearing of rocks, and the shear zone is very problematic when located in dam project near the dam site. Different type of faults. We are going to see normal fault, when the blocks is moving downwards along the fault plane. Reverse fault, when the block is moving upward, it becomes thrust. If the fault plane dipping very less than 45 degree in 2.5, 10 degree, 20 degree is recognized as thrust, and the nape in mountainous area, for example, Almora nape, is formed by the thrust fault. Strike slip fault, in which the movement is essentially horizontal under the action of shearing stress, and this type of fault is associated with folding and tearing of the rocks. Pivotal fault, as the name indicates, pivotal, it is fixed on the axis. In a pivotal, two blocks are joined at a certain part as a pivot, and it appears like a normal fault on one side of the pivot, whereas on the other side it is a reverse fault, therefore recognized as pivotal fault. The interface between the two blocks is the pivotal part. The term hinge fault denotes the type of fault in which the relative displacement of two blocks increases away from one another of the fault, which act as the hinge fault of the two blocks if following the hinge. Next important aspect, the effect of faulting in brittle and ductile region. So as far as the concept of stress strain deformation is concerned, the majority of faults form in brittle zone. However, some of the fault is also formed in ductile region or semi-ductile region, and due to this there is a change in features like formation of cataclastic, dynamic crystallization, deformation is a grain like undulage extension, etc. The process of brittle deformation is dominating in case of fault formation. The sum of the clue related to identification of fault is here. Valley running straight for a long distance is indicative of fault, and the juxtaposition of younger bed with older strata is evidence. Offset of sedimentary also one of the evidence. Offset of quartz stringers or pegmatite veins is an indication of fault, and the presence of fault can understood on the basis of tension joints and others, and the polished surface on the fault surface also indicator. Presence of the breccias related to fault is also indicators. Sequencites also. Beside this, we have another type of structure that is called as joint, and joint having no displacement, it is a simply fracture. The joints may be of the tectonic origin, be related to tectonic forces, and related to unloading joints when the stress is released due to erosion and due to excavation of strata. Exfoliation joints, this is the related to the first case of the unloading joint formed parallel to the present land surface in the region of in the rocks of high compressive strength like in granite. Besides this, the joints also present in different type of rocks. The joints mainly present in sedimentary rocks, showing different deeps and strikes and others, and we can observe number of joints in limestone, sandstone, claystone. And the joints in igneous rock, mainly we have three types of joints, namely cross joint, longitudinal joints, and flat-like joints. And the columnar joints and others are very famous. Columnar joints, and then radial joints and radial fractures joint arranged in radial pattern form in lava flow. These are the related to joints formed in extrusive rocks. and some limited in intrusive rocks. So columnar joint is a characteristic of basaltic rock, and this radial joints also characteristic of basaltic and rhyolitic rocks. These are extrusive rocks showing flow. We can observe number of such joints in Deccan Trap province of India and in some Himalayan region. Beside this, we have joints related to compression, tension and shear. Compression there is a very rare, but the compression induced tension is also a cause behind the formation of joints. Friends, these materials I have prepared mainly from the book written by Shobindo Gangopadhyay on engineering geology, published by Oxford University Press, and page wise it is a rich in page ranging from 1 to 549. Then partial support from the book written by Well F.G. in 2007 named Engineering Geology, also a thick book having page 1 to 551. And the Kashabulu partial support from the book Textbook of Engineering Geology written by Kashabulu NC is also ranging in page from 1 to 495. Friends, today we have discussed about the faults, anatomy of faults, different elements of fault, and faults are related to tectonic and metamorphic origins, and the fault is formed due to tectonic forces in brittle domain, and some of the faults also form in ductile and semi-ductile zone. And the fault shows displacement along the fault planes. If it is a downward movement, then it is a normal fault. If opposite to this, then it is recognized as reverse fault. If along the strike left and right, it is recognized as strike fault. And the fault can be classified on the basis of geometry and genesis in different categories. And beside this, the joints differs from the fault due to lack of displacement. There is no displacement at macro and mega and mesoscopic scale, maybe some displacement at microscopic scale. And the joints are also related to tectonics and non-tectonic origin. In tectonic origin, the folded zones, when there is a release of stresses, there is a formation of joint, and the joint formation is representing the last phase for the release of stresses. Due to unloading also there is a formation of joint due to erosion, due to release of the stress by excavating the rock strata and others. Beside this, the joints can be categorized as tension joints, shear joints, radial joints, and the joint associated with sedimentary rock, metamorphic rock, and igneous rock, mainly igneous rock like columnar joint, like radial joints, etc. Friends, today we have elaborated about the concept of fault, joints. We have discussed in detail about the elements of fault, different type of faults, and the characteristic stress condition in which a particular type of fault is formed. Then about joint, classification of joints in different types as related to tectonic origin, non-tectonic origin, related to tension, related to shear, are associated with sedimentary rock, igneous rock, etc. Rest of geological structures and their impact on dam foundation and tunnels we will discuss in our next classes. Thank you very much.